Have you ever wondered where humanity's magnificent journey began? From the first organic molecules in the primordial ocean until we stood upright and looked up at the stars, the story of evolution is a dramatic epic. This is not just the history of one species, but a symphony of life, a relentless struggle to rise from the mud to finally master this blue planet. Join us as we unveil the secrets of this miraculous evolutionary process. Welcome to SpaceTime's universe journey of discovery, where we explore the deepest mysteries of the universe. In this video, we will explore the evolution of humanity, the struggle from the mud to master Earth. Don't forget to subscribe to the channel so you don't miss out on other exciting universe exploration videos. If you find the video interesting and useful, please like and share to support us.
Our planet, about 4.5 billion years ago, was a chaotic, lifeless fireball. After hundreds of millions of years, the surface gradually cooled. Water condensed to form primordial oceans, and a primitive atmosphere began to form, with gases like methane, ammonia, water vapor, and carbon dioxide, under the influence of ultraviolet rays and lightning strikes. In that harsh environment, inorganic molecules gradually combined into simple organic compounds, such as amino acids and nucleotides. The famous Miller-Urey experiment demonstrated this capability, successfully recreating some basic building blocks of life in laboratory conditions simulating early Earth. Over millions of years, these organic compounds continued to interact, forming more complex polymers, such as proteins and nucleic acids. A major turning point was the emergence of self-replicating molecules.
About 3.8 billion years ago, the first cells appeared, enclosed by a lipid membrane to protect their internal components. These were primitive, single-celled organisms, living on chemical reactions in the environment, marking the beginning of life on Earth. Throughout the next billion years, these single-celled organisms continued to evolve, developing more complex mechanisms for survival and reproduction. The emergence of photosynthesis in cyanobacteria completely changed the atmosphere, releasing oxygen and paving the way for aerobic life. The increase in atmospheric oxygen created a favorable environment for the development of more complex organisms. About 2 billion years ago, eukaryotic cells emerged with more complex structures, containing specialized organelles, such as mitochondria and chloroplasts, marking a major leap in evolution.
The next turning point was the cooperation of single cells to form multicellular organisms. This allowed cell specialization, creating tissues, organs, and ultimately more complex bodies, opening up an era of immense biodiversity. About 540 million years ago, Earth witnessed the Cambrian explosion, a period of rapid diversification of life where most modern animal phyla appeared. In a relatively short time, countless new life forms evolved, from simple organisms to the first vertebrates. Among the Cambrian organisms, the first vertebrates appeared in the form of primitive jawless fish. Over millions of years, these fish developed jaws, fins, and other skeletal structures, adapting to a variety of diverse aquatic environments. Around 375 million years ago, some lobe-finned fish began to adapt to terrestrial environments. Their fins gradually transformed into limbs, allowing them to move on land for short periods, seeking food or avoiding predators.
From these first amphibians, reptiles evolved, developing the ability to lay eggs on land and waterproof skin, making them completely independent of aquatic environments. This opened the Mesozoic era, where reptiles, especially dinosaurs, dominated Earth. Throughout the Triassic, Jurassic and Cretaceous periods, dinosaurs evolved into countless forms and sizes, from gigantic herbivores to fearsome predators. They dominated terrestrial ecosystems for over 160 million years, a testament to the success of evolution. However, about 66 million years ago, a mass extinction event occurred due to the impact of a giant asteroid with Earth. This event wiped out most dinosaur species and opened a new era, creating conditions for the rise of mammals. Mammals, which had existed as small creatures hiding in the shadows of dinosaurs, had the opportunity to thrive. They rapidly diversified, occupying empty ecological niches and becoming the new dominant species on the planet.
Among these mammals, a small branch evolved into primates, living primarily in trees. Binocular vision, flexible fingers, and a relatively large brain were important characteristics that helped them adapt to life in the jungle, gathering food and avoiding danger. Around 6–7 million years ago, due to climate and environmental changes, some primate species in Africa left the dense forests to adapt to the savanna environment. This was the beginning of the hominin lineage, the direct ancestors of modern humans. One of the most important advancements was the development of bipedalism, walking upright on 2 feet, in species like Australopithecus. This posture offered many advantages: a wider view of the savanna, the ability to carry items, and freeing the hands for tool use. About 2.8 million years ago, Homo habilis, or handyman, appeared, known for their ability to create and use the first crude stone tools. The use of tools marked a turning point, allowing them to exploit food sources more efficiently and better protect themselves.
The brain of Homo habilis also began to grow larger, indicating an increasing capacity for thinking and problem-solving. Reliance on tools and social skills became key factors for the survival and development of this species. Next, about 1.8 million years ago, Homo erectus, or upright man, appeared. This was the first hominin species to migrate out of Africa, spreading across Asia and Europe, demonstrating the extraordinary adaptability and exploratory spirit of our ancestors. Homo erectus was also the first species to control fire, a revolutionary skill that provided warmth, protection from predators, and allowed for cooking food. Cooking food improved nutrient absorption, promoting grain development and reducing tooth and jaw size. The nomadic lifestyle and the use of fire helped Homo erectus develop more complex social structures, with cooperation in hunting and division of labor. This laid the foundation for later cultural and technological development. About 400,000 to 40,000 years ago, Homo neanderthalensis, or Neanderthals, developed in Europe and parts of Asia. They were powerful hunters, well adapted to the cold climates of the Ice Ages, and showed evidence of culture, burying their dead, and even rudimentary art. Around the same time, Homo sapiens, or wise man, appeared in Africa about 300,000 years ago. With a superior brain, abstract thinking ability, and complex language, we began an unprecedented cognitive revolution. This cognitive revolution allowed Homo sapiens to develop more sophisticated communication, planning, and cooperation skills. Cave art, jewelry, and the first religious symbols are evidence of our abstract thinking abilities and rich inner world. About 70,000 years ago, Homo sapiens began the Great Migration out of Africa, spreading across the world, replacing or assimilating other hominin species like Neanderthals. Superior adaptability and advanced technology helped us conquer every environment. By mastering hunting and gathering technology, Homo sapiens became the top of the food chain. However, this nomadic lifestyle did not allow for the creation of complex social structures or the accumulation of large material wealth. About 12,000 years ago, the agricultural revolution occurred, a major turning point in human history. Humans began to settle down, cultivate food crops, and domesticate animals, abandoning the nomadic hunter-gatherer lifestyle. Settlement and a stable food supply led to a significant population increase and the formation of villages, then cities. Agriculture not only provided food, but also created surpluses, allowing for labor specialization and the development of crafts. From the first cities, great civilizations arose in Mesopotamia, Egypt, India, and China. These societies developed writing systems, laws, governments, religions, and arts, laying the foundation for the development of human civilization. The invention of the wheel, metallurgy, and other tools spurred the development of trade and transportation. Powerful empires emerged, expanding their influence and knowledge across the world, though often by force. About 500 years ago, the scientific revolution began, changing the way we perceive the world. From Copernicus's heliocentric theory to Newton's laws of physics, humans began to understand the natural laws and the universe more clearly through observation, experimentation, and reasoning. Along with the scientific revolution, the age of discovery opened as European navigators explored new continents, connecting the world and leading to the global exchange of cultures, goods, and even diseases. In the 18th and 19th centuries, the Industrial Revolution erupted, using steam power and later electricity to operate machinery, producing goods on an unprecedented scale. This led to rapid economic growth, urbanization, and profound changes in social structure.
However, the Industrial Revolution also brought major challenges: environmental pollution, harsh working conditions, and wealth inequality. Humans began to significantly impact Earth's natural environment. The 20th century witnessed remarkable advancements in science and technology, from automobiles and airplanes to computers and the Internet. 2 world wars caused devastation, but also spurred rapid progress in medicine, engineering, and materials. Today, we are living in the information age and the digital technology revolution, where information is transmitted instantly and artificial intelligence is reshaping how we live, work, and interact. The ability to compute and analyze data has reached extraordinary levels. As the dominant species, Homo sapiens faces unprecedented challenges. Climate change, biodiversity loss, resource scarcity, and social inequality threaten our own future and that of the planet.
However, with intelligence and the ability to cooperate, humanity also has the potential to solve these problems. Developing clean energy, preserving the environment, space exploration, and advanced medical research are promising directions. We have risen from the mud, overcome countless challenges to become the architects of this magnificent civilization. The journey from simple cells to complex architectural marvels, from rudimentary cries to majestic symphonies, is an epic of will and intellect. Our capabilities are constantly expanding, from understanding atomic structures to exploring distant galaxies. Every invention, every discovery is a testament to humanity's unceasing desire to better understand ourselves and the universe around us. From the first stone tools to quantum supercomputers, from cave paintings to digital artworks, we have demonstrated infinite creativity and learning ability. Humanity not only exists, but also reshapes the world in its own way.
We have created towering cities, complex machines, and global communication networks. This development is the result of millions of years of evolution, accumulating knowledge and experience through generations. Standing at the pinnacle of evolution, we carry both responsibility and opportunity. The responsibility to protect the planet, and the opportunity to shape a future where wisdom and compassion lead the way. The journey from the mud to mastering Earth is not a finished story. It is an ongoing epic, with each generation adding a new chapter, full of promise and challenges. Our journey, from cosmic dust to complex civilizations, is a powerful testament to adaptability and the unceasing desire to advance. We have conquered land, explored the seas, and now our gaze turns to the sky. So, how did our ancestors, the people of ancient civilizations, perceive the universe? The next video will take us back in time to explore their early understanding of the cosmos.